Now, let's look into the concepts of state in React. When introducing React, I mentioned an example about the like button. If a user clicks this like button on the web page, the appearance of this button changes dynamically by JavaScript without refreshing the page, I said. To make it easier for developers to implement this, React uses something called state. For instance, to create this like button, we can declare a state called like. Depending on what value is contained here, that's what the screen renders. When the value of like is false, a button like the one on the left is rendered. When this value becomes true, the screen is re-rendered to display a button like the one on the right. Let's dive into our first example. Please code the app component just like this. To render it just like the lecture, all you need to do with CSS is this. From this point on, we'll be importing something called useState from React. In actual projects, you can think of it as a feature that's always imported. As you can see in the usage below, you can tell that it is a function. You'll see it being executed with 0 as an argument in the brackets on the right. However, this piece of code might feel unfamiliar to some of you. It's code that assigns the result of executing useState to something with an array format on the left. As in the code line above, let's print the output of executing useState with 0 as an argument. You can see that it returns a function with an array containing 2 elements. The first element is the 0 we put in as a parameter, and the second is some kind of function. Those of you who have studied JavaScript above the basics would know this is array destructuring. Suppose you have an array like this and you need to store the first 2 elements in 2 external constants or variables. For those who don't know destructuring, you might have thought of something like this. Declare 2 external constants. Then assign the first and second values from the array by accessing them using their indices. So A will store the first element A and B will store the second element B. But if you use array destructuring, you can implement the same functionality as follows. You create 2 constants called A and B, and the first and second values of the array get assigned to them, respectively. This part here is employing something called destructuring. The useState function returns an array, and the contents of the array are being assigned to the constants count and setCount. The state for use in this component gets returned as the first element of the array and is named count. This value is initialized with the value inserted as an argument in the useState function. Hence, you can see there's a 0 on the right hand side rendered that way. The second item is a setter function that can change the value of the preceding state and reflect the result on the screen. Here you can see it's being used to handle the onClick event for the buttons. So if you click on the buttons after running this, you'll see the number on the screen increase or decrease accordingly. The key point to note is that the content of a web page can change without the page being refreshed. This is called re-rendering. You should write the code, run it in developer mode, and then test it. What to remember here is, as we learned in the last video, the thing that goes here must be a function. Please be aware that it's not the execution statement of setCount, but a function that executes setCount that gets written in this location.
But do we really have to do it this complex way? Instead of using state, I feel like we could just create a variable called count, and then write a function to modify this value.
Let's modify the code in that way and test it again. As you can see, no matter how much you click the button, the 0 on the screen does not change. If you look at the console log, you can see that the count variable keeps changing its value, but the change in that value is not reflected on the screen. The function returned as the second element by the useState function not only changes the value of the state returned as the first element, it also re-renders the corresponding element of the web page each time the function is called, and the value changes to reflect the change. This is exactly what the state is used for. Let's move on to the next example. It's merely the same concept applied in a different form. In this example, we use a state to indicate whether it is pinned. A state, much like a variable or a constant, uses a name to represent what state it is pointing at. The following function is typically named in the form of a setter that assigns a value to it. In the case of this state, as you can see, the initial value is specified as false, not just numbers, but Boolean, strings, objects, arrays. Any value can be used in the state. The button has a toggle pinned function set as an event handler, which internally calls the setPinned function. This function works by reversing the value of isPinned each time it gets executed, thereby implementing toggling. If isPinned is true, it changes it to false. If it's false, it changes it to true. Only when isPinned is true, a pinned emoji is attached at the beginning like this, in the case of the button. Therefore, when you run it and press the button, you can see the emoji appearing and disappearing in a repeated manner. This kind of code can be used to toggle something like or subscribe. Let's move on to the next example. If this example doesn't make sense to you, feel free to skip it. This is the code implemented in both the first and second examples. In both of these examples, the new value is set based on the previous value of each state. For count, the value that has been either incremented or decremented from the previous one becomes the new value, and for isPinned, the value that reverses the previous one becomes the new value. In such cases, you can put functions like this, not modified values, into the setter functions. It's a function that returns a new value based on the previous value. In the setCount function, you put a function that adds or subtracts 1 from the given parameter. In the setPinned function, you put a function that inverses the given value using the negation operator. Of course, the value given as a parameter here means the previous value. If you test it, you can see that it works properly. If this part is difficult, it's fine to just remember that there's such a thing and look back at it later. Let's move on to the last example. This example might be difficult, so if it is hard for you to understand right now, you can just watch this and then look again later. Because the code of the app component is long in this example, I have opened it in two tabs like this. On the left is the top part of the app component code, and the bottom part is shown at the bottom. Thus, it is a code written in one file. Please pause for a moment and take a rough look at the code. It's the code to create a to-do list page, like the one on the right. Let's take a closer look at the code progressively. Firstly, the to-dos state, which represents tasks, has been used. To-dos are written as an array of strings for the initial value. So here, an array of strings is being used as the state, and this array is mapped, as shown on the right, appearing on the screen as list items. This time, let's take a look at this delete button in each list item. It is likely made for the purpose of deleting each item from the list. For this, we have defined a function called deleteToDo. It's a function that removes the clicked item from the array. Normally, you may use the splice method like this to remove a certain element from the array. However, changing the to-dos array itself like this will not cause the screen to be re-rendered. As I mentioned earlier, in order to reflect changes on the screen, you need to use setToDos function like this, and newArray, that is, the array after removing the deleted items from the original array, should be put in as an argument. This code uses the filter method to return a new array that removed an item at the given index from the original array. Simply put, it's a code that removes the nth element from the todos array when you click the delete button on the nth item. Let me briefly explain functional programming in JavaScript for those who are not familiar with it. In the filter method of an array, you put a function that is used to return true or false. An array is newly created and returned, which only collects elements in the array that return true in this function. If a second parameter is used in this function, it represents the order of each element. If it's the first element, it's 0. If it's the second element, it's 1. Therefore, if the return value of this function is written like this, a new array that contains elements that are not in the order of the number given as index is returned from the filter. If the index is 1, it returns a new array that removed only the second element. It's how you remove the nth element in this way. When a user clicks the delete button of the second item, it returns a new array excluding the second item to put in as an argument to setToDos. So when we test this, you can see on the right that the function to delete items is working successfully. You can easily understand after looking up the filter method of the array and its callback function later. This time, we're going to create a feature that adds items to this list. To do this, I added elements like this to the screen, an input field to enter a new to-do, and a button used to add it to the list. Take a moment to pause the video and take a look. And I added a string state called newToDo. This is the value used to write a new item to put in the to-dos array above. It is rendered in the p element on the right and is also connected as a value in the bracket expression of the input element. Conversely, when this input changes in value due to input, the changed value is transferred to new to do through the set new to do function. Now, if you enter text in the input field, you can see that the value changes in real time and is rendered, which is indicated by the text appearing right above. Now, this new to do contains the value make a website that I just entered. If we add this string to the to-dos array above, you can see it appear as a new item in the list on the right. Lastly, we add an add to do function for this, and all you need to do is connect it to the add new task button on the right. Remember, even when adding elements to the array, it will not re-render just by changing the items inside the array. Like the splice method, the push method also just adds items to the array, so there's no change on the screen. So, like this, by using the spread syntax, we create a new array with new to do, added at the end of the existing array, and run it as an argument into the setToDos function. Just like you spread an object, array spreading is used when you want to create a new array using elements from an existing array. Let's say we have an array like this, called array1. By using the spread operator with it in a new array like this, it copies all values from that array. As a result, a new array that includes elements tacked on the back gets returned. Always remember the syntax that is often used when adding elements to the array used as state in React. Now, try pressing the Add New Task button from the screen. As you can see, the item has been successfully added to the list. Finally, after adding an item, modify the new to do state to an empty string like this, so that the input field becomes an empty space. I think this example helped you get a sense of how features of a web application are roughly implemented. Next time, we will delve deeper into the concept of state.